So, this is the continuation of the first video. Here we will consider some examples of evaluating double integrals. So, this is the first one, evaluate this integral. Here the evaluation process is very similar to the opposite of the partial derivatives, right, exactly the opposite of the partial derivatives, because here you have two variables. First you bracket this, you can get this bracketed so that the process is easier. So, for the sake of clarity you can introduce a pair of brackets. After that, of course, pair of braces, then here the variable is x. However, you have two variables involved in this integrand. Therefore, you keep the variable y as a constant. You keep y as a constant. So, x is the variable. Therefore, 6y squared can be treated as a constant. So, you leave 6y squared. It is like integrating 5x. Like if you integrate 5x, you keep 5 as it is, and you integrate x as x squared over 2. So, here 6y squared, you keep it as 6y squared, you integrate this, you get x squared over 2. So, the lower limit is 1, upper limit is 2. Here you better write the variable, because otherwise the variable of our interest. Otherwise, you might substitute these values to the other variable. Now, you can simplify this a little bit. You get 3 y squared x squared. Now, plug in the limits, but the limits are for x. So, first you plug in 2, you get so 3 y squared can be pulled out. When you plug in 2, you get 4. When you plug in 1, you get 1. So, 4 minus 1, which is 3. Then we will move to the next one. So, which is 9 y squared. 3 times 3 is 9. Then it is a simple integral. You integrate y squared, you get y cube over 3. So, you will end up with this one. Now, plug in the limits, you get 3 times 3 cube minus 0, which is 81. Now, we will move to the next example. In this case, you have again both variables in the integrand, and at the same time in the limits you have a variable. Note that here the first variable is y, therefore, you can have or you may have some variables of x in the first integral, but here you should have constants. Now, here the variable of our interest is y. Just to make it little better, you can introduce a pair of braces like this. Now, as I told you, when you integrate with respect to y, you keep x as a constant, like the partial derivatives. So, x is kept as a constant, variable is y, therefore, integrand is xy. It is like how you integrate 4. When you integrate 4, you get 4y. When you integrate simple a, it is ay, like that, xy. Here, this is free of x, therefore, you know how to integrate 2y, it is y squared. So, 2 times y squared over 2. Again, the limits are from 1 to x. Here, you better integrate the variable, otherwise you might, without avoiding the, to avoid the confusion, you better indicate the variable like this. Now, this y squared, these are the limits. Now, you plug in x first and then 1 like this, right. Here when you plug in x, you get x squared, here you get another x squared, minus when you plug in 1 for y, you get x plus 1 like this. Then this 2x squared minus x minus 1, it is a simple integral, you can do it. Here you get x cube over 3, here you get x squared over 2, here you get x, plug in the limits, you will end up with this, right. Now, the third one, this is the integrand, again you have both variables. Here the first variable is x, so you may expect some y as the limit of that integral, of course, here you have it. So, that is okay. Now, again for the sake of clarity, you can introduce a pair of braces just to separate that integral from that mess. Now, variable is x, therefore, the integral is x cube over 3. Here, since the variable of our interest is x, you keep the other variable, that is y, as a constant. So, we have y squared times x. Now, the limits are from 1 to y squared. So, first you plug in y squared for x. So, you get y to the power 6 over 3. When you plug in y squared here, you get y to the power 4. When you plug in 1, you get 1/3. When you plug in 1, you get y squared. Now, subtract. After that, it is a simple integral. Here, since you have 3 in 2 terms, you better pull it out. So, 1/3 you get like this, y to the power 6, 3 y to the power 4 minus 3 y squared, again minus 1. Now, it is a simple integral, you can do it. You get y to the power 7 over 7. Here you leave 3 out, you get y to the power 5 over 5, and you can go on like that. Then plug in the limits. When you plug in 3, you will end up with this. When you plug in 1, you will end up with this. Then you can simplify them, and you will end up with this. So, that is how you evaluate double integrals. In the next video, we will see how we find an area or some kind of a volume using double integrals. Okay. Thank you.